non-homogeneous ODE. So it has two parts. We have the complementary part and the particular part. To solve the complementary part, we reduce this ODE into d squared y plus dx of y plus dy over dx is equal to 0. So that is part of the complementary. And to solve this, we let our solution to be of the form y is equal to m to exponential mx. We differentiate it once to get y prime as equal to m exponential mx. We differentiate it again to get y double prime as equal to m squared exponential mx. Then we substitute the values here to have m squared exponential mx plus exponential mx, which is equal to 0. Factoring exponential mx, we shall have m squared plus 1, which is equal to 0. And we note that exponential mx cannot be equal to 0, which tells you that m squared plus 1 is the one which is equal to 0, implying that m squared is equal to -1, meaning that our m1 is equal to m2, which is equal to plus or minus I, taking square root on both sides. So that now here we have our y complementary as equal to c1 sine of x plus c2 cos of x. c1 and c2 are essential arbitrary constant. Then we go to the part of y particular. Given ODE will be given by this, which can be written as 1 plus d squared exponential power 1 multiplied by x plus 1 that way. Then from there now we expand the part with 1 plus d squared using Taylor series as 1 minus d squared plus d power 4 minus d power 6 multiplied by x squared plus 1. Yp is equal to 1 because of this one and this minus 2. The other part then plus x squared. D squared means you differentiate x twice. So when you differentiate x once, it is going to give you 2x. When you differentiate 2x, you will get x. I mean, when you differentiate 2x, it will give you 2. The other part will be reduced to 0. So this part will return to 0, and this other part will return to 0. So our IP of the given ODE is equal to that. So our solution, y will be given by our y c plus our y p. So our yc was equal to c1 sine of x plus c2 cos of x. So we combine these two so that now we get our y as equal to c1 sine of x plus c2 cos of x plus x squared minus 1. That is the solution of our given ODE. Thanks so much for taking your time to study with me on how to solve nonlinear, on how to solve complementary and the particular part of non-homogeneous ODE when the part of non-homogeneous Rx is of the form x power m. So it is a polynomial. Bye bye. Thanks so much. See you in the next presentation.